So, what is a logarithm? In words, log base a of x is the power that a must be raised to in order to get x. In the box at the bottom of page 1, that is the definition of a logarithm. It says log base a of x is equal to y. That statement is equivalent to a raised to the y power is equal to x. Okay, here's a nifty little trick that you can use to remember this rule. Okay, so if I have log base a of x, okay, is equal to y. Okay, take this statement. The little tiny number is going to be the base of the logarithm. Okay, any positive number other than 1 can be the base of your logarithm. Okay, remember exponential functions have bases and logarithms also have a base. Okay, but here's what you're going to do. When you see this statement, okay, we're going to do this arrow thing. You translate this as a to this power gives you this. Okay, so a to the y power gives you x. Okay, if you can remember that arrow thing, then you will get your logarithms correct. Okay, so let's do some practice. At the top of page 2, in example R1, it says find the exact value of each logarithm, then change each logarithmic statement to an equivalent statement involving an exponent. Okay, so basically in this particular example, I've got some logarithms that we're going to make sense of. And there's two columns. There's a logarithmic form and there's an exponential form. So basically what we have in the first column under the logarithmic form, we have a bunch of logarithms. And you can tell it's the logarithmic form because you see log or you see ln. Okay, if you see one of those two things, you know you're dealing with a logarithm. Okay, in the exponential form column, what we're going to do is rewrite the logarithmic statement, okay, in exponential form. It will not have a logarithm present, okay? It's kind of like the exponential form is used to explain the logarithmic form, okay? All right, let's get started. We're going to do this, okay, let's just start with part A, okay? In part A, we're trying to figure out what the log base 6 of 216 is. It's going to equal some number, but we've got to figure out what that number is, okay? So again, the base here, every logarithm has a base. This is base 6. So if you do the arrow thing, okay, this is telling you, if you take 6 and raise it to this power, you should get 216, okay? So what we can say, okay, we're trying to figure this out. 6 to what power gives us 216? Well, let's figure that out. 6 to the first power is 6. 6 to the second power, 6 squared, that's 36. Okay, 6 cubed, that's 6 times 6 times 6. Bingo, that's 216. So the answer is 3. Okay, 6 to the third power gives you 216. Okay, so as a result, the answer to this logarithm is 3. Okay, the answer is the power that the base has to be raised to in order to get the bigger number. Okay, you can see the difference between the two forms. Okay, the two statements are equivalent. Log base 6 of 216 equals 3. That's the same thing as saying 6 to the third power equals 216. Okay, the logarithmic form contains the logarithm. The exponential form does not. Okay, all right, let's try the next one. Okay, part B, log base 9 of 1/9. Okay, again, you're going to do the arrow thing. The answer is going to be a number. This time, the base is 9. Okay, if I take the base, what power do I need to raise it to get this bigger number, 1/9? Okay, so to translate it, 9 to what power gives you 1/9? Okay, the answer is going to be the power. All right, so if I start, playing with powers over here, 9 to the first power is 9. 9 squared is 81. Okay, and so on. If I plug in positive powers, I'm getting big numbers. Okay, I need to get 1/9. Okay, so we need to try something else. Okay, 9 to the 0 power. Anything to the 0 power is 1. Okay, that's not 1/9. So let's try negative powers. Okay, what's 9 to the -1? Well, we talked about how you eliminate a negative exponent. You're going to do 1 over the quantity, but change the sign of the exponent. Okay, so 9 to the -1 power is indeed 1/9. Okay, so the answer to the logarithm here is -1. Because if I take 9, the base, and raise it to the -1 power, that's going to give me 1/9. Okay, so again, the statement log base 9 of 1/9 equals -1, that is equivalent to the exponential expression 9 to the -1 equals 1/9. They say the same information. Okay, moving on to part C. Okay, log of 10,000. Okay, this one's different than the logarithms we've seen so far. Why? You don't see a base. Okay, there's no little number there. Okay, so here's the deal. If you just have log, it is understood to be a base 10 logarithm. Okay, so you can write that in. Okay, if you are dealing with a base 10 logarithm, usually you're not going to see the base written down because it's understood to be 10. Okay, so I'm going to come up here and write a big note. If you see log, the base is 10. Okay, you can write it in if it helps you. Okay, so here we're going to do the same thing. 10 to what power gives us 10,000? Okay, again in exponential form, 10 to what power gives us 10,000? Okay, well, 10 to the first power is 10. 10 squared is 100. 10 cubed is 1,000. 10 to the fourth is 10,000. Okay, so the answer is going to be 4. Okay, log base 10 of 10,000, or just log of 10,000, is going to be 4. Okay, because if you take the base 10 and raise it to the fourth power, you're going to get the quantity 10,000. Okay, in part D, you see ln of e to the fourth. Okay, again, there's no subscript. There's no little number. Okay, and instead of log, you see ln. Okay, ln is called the natural logarithm. It's a special type of logarithm, just like plain log is. Okay, ln is base e. E is the base for ln. Okay, by the way, a base 10 logarithm is called a common logarithm, and a base e logarithm is called a natural logarithm. Okay, even though we've got a funny base, e is considered a weird base, I guess, it's going to work the same way. Okay, go ahead and write in your base. Okay, if I take e, okay, the little number, the base, what power do I have to raise it to get the quantity e to the fourth? Okay, e to what power gives me e to the fourth? Okay, to make those two sides match over here, 4 has to go in the blank. Okay, so the answer here is 4. Okay, all right, so that's how that works. Okay, even though it's a natural log and the base is e, it's going to work the same way. Okay, something I want to mention, and this is going to be helpful when we do parts E and F. ln and log are really very prevalent for logarithms. Okay, you're going to see a lot of logs and a lot of natural logs. Okay, so if you look at your calculator, you actually, on the keypad, if you look at where my arrow is, you have a log button and you have a natural log button. Okay, and like I said, there's tons of different bases. Any positive number other than 1 can be a base for your logarithm, but you don't see on the keypad, you don't see a button for log base 6 or a button for log base 4. Those are on your calculator somewhere buried in one of the menus, but since you're going to use base 10 and base E all the time, those buttons exist on the keypad, okay? We could check what we did in parts C and D really quick. You could actually, let's go down here. For part C, we could have punched in log of 10. Oops, I hit Ellen. You could hit log of 10,000. Okay, and you would get 4. Okay, or we could have punched in natural log of e to the 4th. Okay, and it would have given us the quantity 4. Okay, so you can, you have these log and ln buttons at your disposal on your calculator. Okay, but log is specifically for base 10. ln is specifically for base E. They don't do the same thing. Okay. All right. In part E, okay, what's the log of 0? Okay. Well, in this situation, again, it's log, so the base is understood to be 10. 10 to what power gives you 0? Okay. What do you raise 10 to get the 0 power? Okay, and you think about it, you're like, I don't know. Okay, well, let's take a look at the calculator. I've got to hit log, not ln. Okay, log of 0. Guess what happens? You get a big error message. Okay, so this is actually undefined. Okay, there is no power you can raise 10 to get 0. Okay, let's do part F. Okay, here we've got natural log, so the base is understood to be E. Okay, what power do I raise E to get negative 12? Okay, so E to what power gives me negative 12? Okay, again, you have to think about it, think about it, think about it. This one's hard because, you're dealing with a base E. Okay, so let's just punch it into the calculator. Okay, if I hit natural log of negative 12, I also get an error message. Okay, so we can go ahead and say this is undefined. Okay, here's what's going on with parts E and F. Okay, I have a note underneath the 2 columns here, and it says we can only take the logarithm of positive numbers. That is, we cannot take the logarithm of any negative number or of 0. Okay, so that's why in part E, okay, the base is irrelevant. If you're taking the logarithm of 0 or negative number, you're going to get an error. It's undefined. So in part E, you can't take the log of 0 because you're taking the log of 0. You can't do that. Okay, that's undefined. And in part F, you're taking the logarithm of something negative. That's not allowed either. Okay, this is very important. Okay, this red statement, very, 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 very important. You cannot take the logarithm of any negative number or of 0. Okay, on the other hand, okay, if you have an exponential function and you wanted to plug in 0 or a negative number as your input, that's okay. Okay, so you don't have to worry about that issue with exponential functions. You can take the exponential of something negative or of something 0. You just can't do it for logarithms. Okay, so please, please, please remember that red statement.